Hello everyone, welcome to another episode of Pyathlon. In today's video, we'll be discussing Amazon Elastic MapReduce, or EMR for short, so without further ado, let's dive right in. We will begin our discussion by talking about what is Elastic MapReduce, We'll begin our discussion by talking about what is Elastic MapReduce, which we'll be referring to as EMR for the remainder of the video. What EMR is, it's a platform built to analyze vast amounts of data using open source tools. When we use open source tools in this context, we're typically referring to Apache products such as Apache Spark, Apache Hive, Apache HBase, Apache Flink, Hudi, Apache Presto, and more. One benefit of EMR is easy to set up, scale, and automate your big data or your data analytics environment. With EMR, you can provision capacity and cluster tuning, and you can automate those tasks. With EMR, you have the ability to run petabyte scale analytics at 50% of the cost of an on-premise solution, and we'll talk more about the EMR cost drivers either later in this video or in another video. In a nutshell, what EMR is a managed Hadoop framework that runs on Amazon EC2 instances within the Amazon Web Services cloud. Now, you may be unfamiliar with the term MapReduce or what MapReduce actually is, and this video isn't focused on the MapReduce process. It's more of a high-level overview to Amazon Elastic MapReduce, which is a service offered by Amazon Web Services. But just to give you a high-level overview of MapReduce, it's a model that EMR uses to process such vast amounts of data, and it's comprised of multiple phases, notably the map, shuffle, and reduce phase, but it gets its name from the map, which is the first phase, and reduce, which is the final phase. In map, the data is passed through the mapping function to produce outputs, and then its input into the shuffling phase, which produces outputs that is then passed to the reduce phase. And the reduce phase takes that output from the shuffling phase as input and then aggregates it into a single output value, which is the output value you receive at the end of the process. With AWS, you have several options to run EMR. You can run EMR on Elastic Cloud Compute instances, where your EMR cluster will use EC2 instances as nodes. You can also run EMR using EKS, which stands for the Elastic Kubernetes Service. If you're unfamiliar with Kubernetes, it's an open source container development and management system. A container provides a way for you to package your application code, configurations, and dependencies into a single object, and using containerized applications, then you'll be able to run your application easily in many different environments. And you'll be able to run your EMR cluster inside one of these Kubernetes containers. With EMR, you also have the option to create your cluster on-premise and use your own hardware as the nodes as part of your EMR cluster. Now let's shift gears and talk about the actual architecture of EMR. Now, one important thing to remember is we'll be talking about EMR as it relates to your nodes being EC2 instances, but this same architecture sort of applies whether you're doing it on EC2 instances, in a Kubernetes container, or in an on-premise solution. With EMR, you have a master node. You have one master node per cluster, and the job of the master node is to monitor and manage cluster tasks. So the master node distributes tasks to the other nodes, which we'll discuss in a second. The master node also monitors cluster performance. So if you have a node that goes down, it will be the job of the master node to realize that and then take appropriate action. With EMR, you also have core nodes. Core nodes run tasks, so the master node decides what needs to be done, and then the core nodes actually perform those tasks, but they also host data on the core nodes themselves. A task node is similar to a core node in that it runs tasks, but there is no data present on the task node. This was just a high-level introduction into Amazon EMR. If you would like to see more, then please like, comment, and let us know in the comment section. And please subscribe and click the notification bell. We have a lot more EMR content coming in the future. So please be sure to stay tuned so that you don't miss an upload. So thanks for watching, and I'll see you in the next video.